Good morning, everyone. This is the Q&A session 19 from the playlist of electric charges and field. And today I have taken a very simple question. This question is based on the topic of electric flux. So today we will be finding the electric flux which is linked with a coil. The question here is a circular coil of radius 10 centimeter is placed in an electric field given by IE is equal to 1 I cap plus 0.5 J cap Newton per coulomb, such that the unit vector which is outward normal to the surface of the coil is 0.6 I cap plus 0.8 J cap. So we have to find the electric flux which is linked with the coil. So the electric flux linked with the coil is given by ES cos theta, where theta is the angle between the outward normal to the surface and the direction of this electric field. So, and here E is the magnitude of this electric field, or you can say the intensity of the electric field. S is the surface area of this circular coil. And so here this S is already given to us. The magnitude of E will be equal to under root of this 1 square plus 0.5 whole square. So this will be equal to under root 1 plus 1 by 4, which is equal to root 5 divided by 2. So the magnitude of the intensity of electric field is equal to root 5 by 2 Newton per coulomb. Now S, the radius of this circular coil is 10 centimeter, and so the here the value of this surface area will be equal to the area of this circular coil, which is equal to pi r square. So this is equal to pi is equal to 22 by 7, and r is given by as 10 centimeters. So I will be converting into meter, which will be equal to 1 by 10 into 1 by 10. So this will be equal to 7 into, this is equal to 22 divided by 700 meters square. Now here we have to find the value of cos theta, and here theta is the angle between the outward normal to the surface of the coil and the direction of the electric field. So here we know that the dot product of two vectors is given by, if A and B are two vectors, then the dot product of two vectors is given by mod A mod B cos theta. So here let us this vector A can be taken as the vector E here, which is equal to 1.0 I cap plus 0.5 J cap dot B. So here the unit vector which is outward normal to the surface of the coil is equal to 0.6 I plus 0.8 J cap, and this is equal to mod A. Now mod A here is the magnitude of the intensity of electric field, which is equal to root 5 by 2, and the outward normal to the surface of the coil is given by this unit vector. So the magnitude of this unit vector will be 1 into this cos theta. So finally, what I will be getting here is, see, now 1 I cap dot 0.6 I cap, this will be equal to what? 0.6 I cap dot I cap plus, now I cap dot I cap is equal to 1. ठीक है, We know that the dot product of two vectors is equal to, is given by this formula. Now, so if I put the value of A as I cap, B as I cap, then I will be getting this. Now the magnitude of the unit vector is 1. So this will equal to 1 into cos 0, because the angle between these two vectors is equal to 0. So which will be equal to 1. So the dot product of this I cap and I cap will be equal to 1. Similarly, the dot product of I cap and J cap, this will be equal to 0. And the dot product of J and I will be also equal to 0. So finally what I will be left with will be 0.6 I cap which is equal to 1 plus 0.5 into 0.8 which is equal to 40 divided by 100 equal to 0.4. 0.4 J cap dot J cap, and this is equal to root 5 upon 2 cos theta. Now, this can be written as, it implies that 0.6 plus 0.4, this is equal to root 5 upon 2 cos theta, or it implies that cos theta will be equal to, this is equal to 1, so this is equal to 2 upon root 5. So we have found the value of cos theta, and now simply we have to substitute this value in this equation. So I am just writing it here, the value of cos theta here as cos theta is equal to 2 upon root 5. And this surface area of this circular coil was equal to 22 by 7, and R was equal to 1 by 10 meters, so that was equal to 700 meters square. So now I will be substituting the value of E, S and cos theta in this equation, that is phi is equal to, E is equal to root 5 upon 2 into, this will be equal to 22 by 700 into cos theta. Cos theta is equal to 2 upon root 5. So this gets cancelled out. So finally the flux which is linked with the coil is equal to 200 divided by 700, and this will be, the unit of this flux will be equal to Newton per coulomb meter square. Or we can simply write this, if we want to simplify, you can write it down as 11 by 350 Newton meter square per coulomb, and the value of the flux will be equal to 11 divided by 11 divided by 350, which is equal to 0.013. It is equal to 0.0314 Newton meter square per coulomb. So the electric flux linked with the coil is equal to 0.0314 Newton meter square per coulomb. So thank you very much for joining this session. In the next session, again, I will be coming up with a different topic from the same chapter, that is electric charges and fields. So till then, have a nice day. Bye.